The next two functional groups that we're going to look at are aldehydes and ketones. Both aldehydes and ketones have a carbon double bonded to an oxygen. The difference is an aldehyde has one bond to hydrogen from that carbon double bonded to oxygen, whereas with a ketone, that carbon double bonded to oxygen has a carbon on both sides. So if we look at these compounds, they all have the carbon double bonded to the oxygen. Notice sometimes they do leave off the lone pairs on the oxygen just for simplicity's sake. They are there. Those oxygens are not different. This one, I have carbon bonded to oxygen. One side does have carbons, but the other side has a hydrogen bonded to that carbon. So this is going to be an aldehyde. Because that aldehyde has to be at the end of the carbon chain, I don't need a number to state which carbon that double bonded oxygen is, because since one of those bonds is hydrogen, it has to be the end carbon. So if I count the carbons in this chain, 1, 2, 3, 4, 5, there are 5 of them, so it's going to be pent, and then aldehydes end in -anal. So this would be pentanal. Here I have the carbon double bonded to oxygen, but instead of one of those bonds being to a hydrogen, they're both to carbons. So this is going to be a ketone. So since the double bonded oxygen is not on an end, I do need to state which carbon it's coming off of. So if I were to count from this side, 1, 2, 3, 4, from the right it's carbon 2, so we're going to count from the right. And this would be 2. Again, there are still 5 carbons in the chain, so pent. And then the ketone ends in -anone. So this would be 2-pentanone. This one, carbon double bonded to oxygen, still has carbons on both sides. So again, it is a ketone. But instead of being on carbon number 2, the carbon double bonded to oxygen is on carbon number 3. So this is 3-pentanone. Notice that you're never going to have a 1-pentanone, because if that double bonded oxygen was coming off of the end carbon, it wouldn't be a ketone, it would actually be an aldehyde.